Well, welcome back everyone to Data Science for Everyone. Today we're going to be looking at tree methods with Pyspark utilizing the dog food dataset. Let's get started. All right, so first off, let's get this started as anything else with everything else. As we do Pyspark from Pyspark, we want here SQL. We want to import our Spark session, and then we're going to create our Spark session with the builder. We want to create an app name, and I'm just going to call this dog food. Get or create. And then we're also going to have our data. So CSV, and this is I believe dog food. Dogfood.csv. We want to infer our schema to be true. We want our header to also be true. And then let's also take a look at our schema once that loads. Okay, so we have our percentages of preservatives in here as integers. And so this is about their mixes, and then whether it's we have whether it's a label including whether it's spoiled or not. So this is very common in a lot of the food industry. So then you're able to calculate up, for example, whether a certain preservative or a certain combination inside of your product is going to cause it to go rancid. So let's also make sure and let's actually just go on and skip down to doing a vector assembler. So from pyspark.ml. Our linear regression, or you know what? Let's actually grab not linear regression. We want our features. We want our vector assembler. Whoops! Why didn't it like that? Oh, whoops, it's because I mistyped Pyspark. From Pyspark ml.feature, import our vector assembler. There we go. And so let's actually go on and do our vector assembler. So we want an assembler here, and we want vector assembler. Our input columns in here are going to be list A, B, C, D. And then we want our output column in here to be features. And so then we grab okay, if you guys didn't notice, since this is just A, B, C, D in here, if you just use list with a string like this, it's faster to actually than typing out the entire list itself. So I was just being a little bit lazy and did some shorthand. So let's create our output data set. Using the assembler, we want to transform our data. And then from pyspark.ml.classification, we want to import our decision tree classifier. We also want a random forest classifier, and we'll just do these two for today. We could also do gradient boosted machines or gradient boosted trees as well, but let's just keep it simple. So for our random forest classifier, you know what, let me do decision tree classifier first. So we'll do decision tree classifier in here, and we want our label column is going to be spoiled, and our features column in here is going to be features. Let's look at our final, or we'll just call it data final in here, and we'll do something like output dot what do we want in here? select, and we want what? Features, and we want spoiled. And then let's go on and run our decision tree model in here. So we'll do DTC, and we'll call this model in here. And so DTC dot fit, and I called it data final this time. That's weird. Data final. Good, and then we can also do DTC here and do model, and let's see if we have what we actually have in here. We can do feature importances. Whoops. Oh, DTC. TC. So we can actually see here which of the, this gives us a sparse vector, okay? And what this actually tells us, for example, is that when we look at feature importances, it's the most important feature overall. So when we look at this feature column, we can definitely see that here index 2 is significantly more important than 3 and or 1. Again, it's at 98% for the most important feature. And this basically means that this is a definitely causing the early spoilage. Okay, so again, this is a great way to actually check this out. Now let's go, and this is just using the decision tree. So let's also go through and do the random forest classifier as well to see if the results are going to change a whole lot. So we'll do RFC is equal to our random forest classifier here, and we want our, I want that to go, there we go. We want our label column in here to be spoiled. We want our feature column. Why does it keep doing that today? Feature column to be features. Run this. And then we have our RFC model. And here is going to be our RFC dot fit. And we want this on our data final. And we can actually look at our RFC model dot feature importances. And again here, we see that definitely feature 2 is still the most significant of all the features that we have. So it's at 92%. So both of these are saying the exact same thing, that feature 2 is definitely causing the spoilage in this instance. Thank you guys so much for watching. If you like this, please comment, subscribe, and hit that like button, and I'll see you guys next time. Bye-bye.